Hey there, my friends. Welcome back. I'm Rob Franek, Editor-in-Chief here at the Princeton Review. And today, folks, we are sharing 14 very important calculus AB concepts for those of you who are preparing the exam in the very near future. Now, AP Calculus is divided into two types, A, B, and B, C. So before we jump in, let's just quickly discuss the differences between Calculus AB and Calculus BC. Now, the first key difference is that Calc AB is supposed to be equivalent to one full semester of college-level calculus. Well, Calc BC is the equivalent of a full year. That all said, Calc AB is much closer to covering 3/4 of a year of college-level calculus. The second big and key difference is that Calculus BC covers more theoretical aspects of calculus and is, objectively speaking, much harder than Calculus AB. Now, the AB exam usually tests more straightforward problems, and you'll find that the problems aren't as tricky or as varied as the problems that you'll find in the BC exam. That is not to say, folks, that prepping for the AB exam will be super easy. Remember that both tests will focus on the basics of differential and integral calculus, and both will prove to be difficult mainly due to the breadth of the concepts that they cover. Now, the standard Calculus AB exam is 3 hours and 15 minutes long with a total of 51 questions. And those questions are divided into two sections with a multiple choice section as well as an open-ended section. And both sections will include a calculator and a non-calculator portion. Okay, now that we have reviewed the basics, we should tackle the key concepts that you'll need to have at the ready come exam day. Concept number one, my friends, limits, asymptotes, and of course continuity. Now, in order to understand calculus, you need to understand limit. Now, limits are the foundation of important definitions and theorems that will be tested throughout the exam. So you should be prepared to evaluate limits not only via equations, but also via graphical, symbolic, numerical, and of course, verbal representations. And you should understand asymptotes graphically and be able to compare the growth rates of different types of functions. You'll also need to be able to determine asymptotes and limits at infinity. Now, the AP exam will also test you on continuity, so you should be able to test the continuity of a function in terms of limits, and you should understand continuous functions graphically. Now, you should also understand the all-important intermediate value theorem, as well as the 4 different types of discontinuities. Now, the first one, jump, second, point, third, essential, and number 4 is removable. That leads us on to concept number 2, which is the definition of the derivative. Now, every problem that you'll encounter on the differential calculus questions will make use of the derivative. Now, of course, hence the name. By test day, you should be able to find a derivative by finding the limit of the difference quotient. And a big hint here, my friends, the difference quotient is a special form of the slope formula. You should also know the relationship between differentiability and continuity. That is, if a function is differentiable at a point, it's continuous there. If a function is continuous at a point, it is not necessarily differentiable there. Leads me to concept number 3, which is basic differentiation. Now, without question, the exam will test your mastery of the basic differentiation rules. So you should understand the applications of the power rule, the product rule, the quotient rule, and of course the chain rule. Now, the exam will also test your ability to find higher order derivatives by taking the derivative of a function more than once. Now, the derivative of the first derivative is called the second derivative, and the derivative of the second derivative is called the third derivative, and so on and so on. And you should be clear on those concepts by exam days. And you should also know how to relate the graph of a function to the graph of its derivative and vice versa. And finally, you should understand the relationship between the sign of a derivative and whether the function is increasing or decreasing. Now, a positive derivative means that it's increasing, and a negative derivative means that it's decreasing. Concept number 4, my friends, implicit differentiation. You should expect to be tested on your ability to use implicit differentiation in cases when you're asked to find the derivative of an equation but can't isolate y in terms of x, meaning that you can't differentiate this equation explicitly. You'll need to know how to take the derivative implicitly. Now, while implicit differentiation is one of the simpler techniques that you need to learn in calculus, it can initially give many students trouble. So be sure to try your hand at plenty of practice problems. You will hear this from me throughout this video. Concept number 5 is, of course, basic applications of the derivative. Now, once you understand the fundamentals of basic and implicit differentiation, it's important to understand the basic applications of the derivative. This includes the ability to find the slope of a curve at a point and the tangent and normal lines of a curve at a point. This also means being able to use local linear approximation and differentials to estimate the tangent line to a curve at a point. You can also expect to see questions related to the mean value theorem for derivative, and of course, Rolle's theorem as well. Be sure to review those applications in full and in detail before the exam. Concept number 6, maxima, minima, and curve sketching. Now, friends, another key concept and one of the most common applications of the derivative is to find the maximum or minimum value of a function. Now, the maximum or minimum of a function occurs at a point where the derivative of a function is 0. These values can be called extreme values, optimal values, or of course, critical points. And it's a truism in calculus that if you don't know what to do, take the derivative and set it equal to 0. You should also be familiar with the extreme value theorem, which explains that if the function is continuous in an interval, then you must always have a maximum or a minimum somewhere in the interval, or else the curve is flat. You should also know how to sketch a curve. This means being able to, number 1, identify the x and y intercepts. 2, find any horizontal and or vertical asymptotes. Number 3, determine the critical points of a function. 4, find the location of the maxima and minima. And number 5 and final, determine the points of inflection. And that brings us to concept number 7, which is motion. Now, you're likely to see some basic problems about motion on the exam, specifically unrelated rates and the relationship between the velocity and acceleration of a particle. For related rate problems, the idea is pretty simple. You'll be given an equation relating to 2 or more variables. Now, these variables will change with respect to time, and you'll use derivatives to determine how the rates of change are related. Almost every AP exam will also have a question on position, velocity, and of course, you guessed it, acceleration. If you have a function that gives you the position of an object, usually called a particle, at a specified time, then the derivative of that function with respect to time is the velocity of the object. And the second derivative is the acceleration. Be sure, friends, to familiarize yourself with these concepts by testing. Concept number 8, exponential, trigonometric, and of course, logarithmic functions. Now, remember all of the trigonometric, logarithmic, and of course, exponential functions that you studied in calculus, pre-calculus, cannot be forgotten, folks. That said, if you're a little bit rusty on them, then be sure to take a refresher, because the AP exam will test your ability to find the derivative and the integral of trig functions and logarithmic functions and of course exponential functions. And also note that a lot of these derivatives and integrals can and should be memorized. Doing so will make it a ton easier to apply the product and the quotient and of course the chain rules to these questions. Concept number 9, my friends, the derivative as a derivative of an inverse function, the College Board will occasionally ask a question about finding the derivative of an inverse function. So you'll need to know how to find the derivative of a function's inverse at a particular point by taking the reciprocal of the derivative at that point's corresponding y value. Concept number 10, integrals themselves. Folks, it is integral for you to know about integrals. Bad jokes aside, my friends, so far, let's just look back. We have covered differential calculus and what you need to know about the derivative, but the exam will also test you on the reverse, how to take an integral. You will need to understand the different purposes an integral serves as the antiderivative. Now, an antiderivative is a derivative in reverse. You should be able to apply the rules that you've learned with derivative to integrals. For example, you should know how to reverse the power rule for antiderivatives and how to use the integration corollary of the chain rule called the U substitution when the integrand is a composite function. Definite integrals. Now, the AP exam will also test you on definite integrals. So you'll need to know how integration is used to find the area under a curve, including how to use rectangles to approximate the area between the curve and the x-axis, how to find the Riemann sum, and how to use the fundamental theorem of calculus and the trapezoid rule. Next, you'll need to understand how the mean value theorem of integrals, otherwise known as the acronym MVTI, applies to integrals. Now, the exam will likely test you on your knowledge of MVTI by asking you to find the average value of a function. Now, while we already mentioned the fundamental theory of calculus, it's important to know that it has two parts of it. There is first the first fundamental theory of calculus used in evaluating definite integrals, and then there's the second fundamental theorem of calculus, which tells us how to find the derivative of an integral. Aim to understand, my friends, both parts of this theorem. And lastly, the exam will also have problems that deal with accumulation functions. Now, they're called accumulation functions because the value of the integral is the area under the curve from the constant to the value x. As x gets bigger, so does the area, hence it accumulates, hence the accumulation functions. Be sure to understand how these functions work overall. Concept number 12, the area between two curves. Now, in addition to understanding the area between a curve and the x-axis, the AP exam will also test your ability to find the area between two curves. Now, this will include the ability to find the area by slicing up the region both vertically as well as horizontally. If you encounter difficulty with this concept, know that you are not alone. Students often have terrible trouble setting up these problems. Fortunately, the College Board asks relatively simple versions of these problems on the exam. That said, be sure to allocate time to practice this concept. Concept number 13. Down to our last two here. The volume of a solid of revolution. Now, folks, this concept is widely seen as one of the most difficult concepts on the exam. And while there are always going to be volume questions on the exam, the good news is that you're almost never asked to evaluate the integral. You'll usually only have to set it up. You'll need to know how to take the region between two curves and rotate it around a line to find the volume of that particular region. And friends, there are two methods to find the volume of a region. Number one, the Washer's method, and number two, the cylindrical shells method. Now, the latter method is more advanced and isn't likely to appear on the AP exam. However, it is still worth familiarizing yourself with both techniques. That said, volumes of solids of revolution require you to sketch the region carefully and to decide whether it'll be easier to slice the region vertically or horizontally. Once you figure out the slice's boundaries and the limits of integration, it's just a matter of plugging into the integral. Friends, with enough practice, finding the volumes will become far easier each time. And folks, once you've conquered this topic, you'll be ready for anything That said, there is another type of volume that you need to be able to find, and it's known as the volume of solids with known cross-sections. Now, in this case, you will be given an object where you know the shape of the base and where perpendicular cross-sections are all the same, regular, planar, geometric shapes. You'll need to understand and to know how to find the side of the cross-section in terms of y. And friends, that leads us to our 14th and final concept on this calculus exam, and it's differential equations. Now, this is, of course, last but certainly not least. You need to familiarize yourself with differential equations. While there are many types of differential equations, only a small number of them appear on the Calculus AB exam. As such, you'll only need a basic introduction to the topic on test A. First, you'll need to understand the method known as separation of variables. If given an equation in which the derivative of a function is equal to some other function, you should be able to determine the original function by integrating both sides of the equation and then solving for the constant term. And don't forget about the big C. Next, you'll need to understand the idea behind slope fields, also known as direction fields. You'll be given a differential equation, but not the equation itself, and will need to know how to make a graphical representation of the slope of a function at various points in the plane. And if this concept sounds daunting, please rest assured that you will only be asked to sketch the simplest ones on the exam. Whew! Friends, we have covered a lot of calculus in these 15 or so minutes, and please know that with practice, as I mentioned throughout this video and preparation, you can totally handle this. If you need some extra help, please do check out our AP Prep book series. The premium edition of our AP Calculus AP book gives you access to 7 full-length practice tests. Friends, that's all for today. If you enjoyed this video, please do give it a thumbs up. And of course, do subscribe to our channel if you haven't already for the latest updates on standardized tests, college admission, extracurricular activities, study tips, and much, much more. Rob Franek signing off for today. Be well, folks.